So, I know the other day I forgot. So, your job for today was to read the mathematical response below. We know that this is incomplete, that this is not a good response. Okay, and then on your warm-up, improve the response using the anchor chart with the mathematical rubric. So, right now I want you to talk to your partner about what are the 4 things, and then this one actually has 3 parts. So go ahead and talk to your partner about the 4 things around the mathematical writing rubric. Go. You guys are done? Yeah. Okay. So make sure. Where can you find, Lulu? Where can you find that mathematical rubric in your binder?
In the resources.
Not in your resources. Axel? You can find it in your homework. Where in your homework? Orlando? On your reflections. They are on your reflections. It's the gray box at the top of the reflections. So that's where you can find it in your binder. Okay. So, the homework, you guys, there was a couple little misunderstandings, but nothing major that we have to review today. Thought you guys did really well. So go ahead, put away your warm-up. Okay, and on your desk have 3.3, the division of rational numbers. James is ready. Okay. This is pretty, today's a pretty interesting lesson because it gives you guys some tools for shortcuts. And yesterday, it was interesting because I didn't teach this yesterday. And no one in this class who got to G, and a number of you did, even recognized the shortcuts. So you guys that are really, that are flying, that are pretty confident about the math, none of you guys saw the shortcut. So make sure you pay attention today. I actually took our focus math and we worked through all of G without any of the shortcuts that I'm going to show today. And it's hard without the shortcuts. With the shortcuts, with you identifying identitive identity and multiplicative identity, oh my goodness, the problems on G get so easy. It's so funny. But I was just trying to see if you guys would see it because I knew today I was going to teach it. So we're talking about multiplicative and identitive identity first. Identitive identity means 0 is the identitive identity number. The reason why 0 is it doesn't change any number that you add to it. Right? Anything plus 0 is that number. 0 plus 7 is 7. But the opposite of adding that number, if I was to subtract the same number, so here 0 plus a is a, but then the opposite, a minus a, is 0. If I have a number and I take that number away, it's 0. It's almost like it didn't exist. Can you think of something that we've talked about where I have something and I have something else and they cancel each other out?
Yes.
What are they called? Yeah. Opposites. Now this is not 4 and negative 4. This is 4 minus 4. That's the additive identity, saying if I have a number and I subtract that same number, I get back to 0. Additive identity is really cool because I can have a huge equation. On this side, I have a number, and then later on this side, I'm taking it away. I don't have to do this work or that work. I can just cancel them out because they equal 0. So today you're going to have to notice that. So A plus B minus A equals B, because they literally go back to 0. I'm taking it back away, so it's 0. Multiplicative identity is a lot like additive identity. 1 is the multiplicative identity number. Because if I do anything, multiply anything by 1, what do I get?
That's the number you're multiplying it by.
The same number. Exactly. The number I'm multiplying by. So 1 times A equals A. In algebra, you guys are going to be constantly looking for multiplicative identity because it makes life easy. And today, when you're doing G1, G2, G3, look for it because it exists in those problems. So if this is true, so is the opposite. A divided by A equals 1. And I love getting 1 because it's such an easy number to deal with. So on your paper, I want you to follow along with me. So if I have 1/2 times 2.23 divided by 1/2. Write that down on your paper. So I'm going to show you how it works. And then your job is to recognize when you have it. This looks like a hard problem. Now, if I rewrite this problem, I'm going to write an equivalent equation. 1/2, and I'm going to change it to x's here because I have a decimal in there. 2.23 divided by 1/2. Okay. These are equivalent. You guys see that, right? All I did is I took this big fraction sign and I turned it into a dividing sign. So what looked really kind of like, whoa, when I write it like this, a little bit easier. And now when I look at this, I see dividing a fraction. Talk to your partner about dividing a fraction. Go. Do you remember? What is it? So, when dividing a fraction, I heard it a bunch. I do copy, dot, flip-flop. So now look what I get. I get 1/2 times 2.23 times, because that's my dot, flip-flop, 2/1. So now, I have a reciprocal. 1/2 and 2/1 are reciprocals to each other. What is a number times its reciprocal?
0?
1. Because look, 1/2 times 2/1 equals 2/2, which equals 1.
But 2 times 1 equals, oh yeah.
So now look at this. This and that equal 1. So I can just get rid of them because it's not going to change this. So what's my answer to this? 2.23. So the key is this, Clara. Can you recognize if I multiply by a number and then later on divide by that same number, that is multiplicative identity. So here I'm multiplying by 1/2. Then what am I doing later on? Dividing by 1/2. Those are going to cancel each other out. They're going to give me 1. It's going to give my multiplicative identity of 1. So when you're working today on G, remember the additive and remember the multiplicative. Don't freak out when you look at those problems. Put that lens on. Okay, that lens, Ben, needs to be thinking of these and searching for those identities. Okay, this is your job. Go ahead and do those with your partner. Oh, wait. This needs to be like this. I forgot brackets. So go and put brackets in like I did, and then work with your partner on those two.
This
Okay. 4, so
Wait, hold on. I'm gonna add it up and like way back there.
I think we get right. I'm just curious.
Okay, so let's look over here now. What do you notice about this problem? This first one. Axel.
There are 2 7.3s.
And so there are 2 7.3s, right? Am I going to be subtracting a 7.3 at some point? Yes. So that means this, and I don't even need to do that work. These cancel each other out. Because what's 7.3 minus 7.3 later? 0. So why do that work? Okay? I don't want to do that work because it's not going to help me. It's going to make it more complicated. So in the end, this problem equals 5.3 minus 1.1, which equals 4.2. How much easier that is, right? Okay, go ahead and tackle the second one.
Okay.
I think it's 4 over 22. 4/22.
Wait.
Lulu, there is no food in my room. Go throw it away. If it wasn't like a problem, I wouldn't have it, but it's been a problem. You can eat out there and you can wait an hour. So what do we think, guys? What do we notice here? Liam.
You can cross off the 2.2s and then the answer is 2.2.
Yeah, because here I'm multiplying by 2.2. And then what am I doing later on? Dividing by 2.2. That's going to give me my multiplicative identity of 1. Because I know 2.2 divided by 2.2 is 1. So those cancel out. What's my answer? 4. Look how easy that becomes. So today, I want you to look for that. Okay, really quickly, I'm going to cover this because I got about 1 minute and then I'm going to let you go. So Dwayne goes from 0 to 15 meters in 5 seconds. He's here, 15. So he goes from here to here in 5 seconds. So he has 1, 2, 3, 4, 5. He's at 5 seconds, 10, whoops. Oh. So it takes him 5 seconds to go that far. So now, this meters per second. Meters per second. You know what that per stands for? Divide. So I literally can plug in my 15 here, my 5 there. I do the division, and I get this rate, which is 3 meters per second. And it's a positive because that number's positive and that number's positive. So over here, I know after 1 second he's 3 meters, 2 seconds, 6, 9, 12, and then 15. This meter per second rate, okay, means meters divided by seconds. And that is going to tell you how fast someone is going. So you kind of need to know this. And today you need to be draw it out because it helps you visualize actually what's happening. Go ahead and do Pascal with your partner because that will take like a minute.
Okay.
So I'm seeing it if it's negative number.
I have told you no food.
Negative 3 seconds after passing 0. I don't know if you.
So you just gotta wait. If I let you eat, knowingly, Riley knows you're eating. I have to let Riley eat. I have to let Clara eat. I have to let David eat. I have to let, and I'm not going to do, I just can't, I can't manage that. Okay? It's not to say you're making a mess. But I can't allow you if I don't allow anybody else.
That's correct.
Make sense?
This is 12 meters, negative second. Yeah, I got negative 4. I know, but it could be negative. I think it's either negative 4. Think about it. It's negative. It might be just like trying to be tricky, but it could easily be 0.
So I was listening to Max and Liam talk. They got an answer of negative 4 meters per second. They took the 12, divided it by the 3 seconds. For whatever reason, 4, 8, 12. Pascal's running backwards. I'm not sure why, but because he can.
But I have something. This is actually a question I had on this. Since it's for meters per second, how I was actually wondering if it, two things. I think it is negative 4, but I'm also wondering if it could be 0, because if it's negative, how would you go negative? But running backwards, you're still going to be going the same speed as if you're running forward.
That's how many meters you went.
Yeah.
Well, that's just too much fast going back.
Yeah, I know.
Maybe he's running forwards but going the wrong way.
Yeah.
Right? Maybe he's confused. All right. Today. Whoops. Why is that not? Today, make sure that you guys are thinking about additive identity and multiplicative identity, because you will need that to be successful. We're going to start on D, then go to G1, G2, G3. Those ones you will need the notes for today. B3, B4, notes from today for sure. Okay? James. Then you're on G. But I want everybody to do G again. If you did G, now put the lens on with multiplicative identity and see how easy it is. I know. And what was great is you did them right without it. But man, once you start looking at it that way, you're like, oh, cancel. Oh my gosh.
Hey, I think you might have a little typo on there. As for starting, it's on D. It couldn't be page 61, but 61 doesn't have D. It's only 62.
Sorry.
Gosh, get it reversed.
Yeah, and I got to take this off too.
Jesus.
Yeah, just D all. Oh. No math rubric on that. I don't know why that was up there. So look over here for a second. I want to show you with D, because I think some of us are tackling this and not thinking about so a quotient. It asks for a quotient, right? A quotient's an answer to a
Division problem.
and it means that it's in simplified terms. That's all. 3 divided by 2, or negative 2, is that as a quotient. Now, I can simplify that and make it negative 1 by 1/2. This is this. This is a quotient. This is an answer. If it's simplified. It's not quite because it's an improper fraction, so I turn it to a proper fraction. That's what it is. Negative 1 and 1/2. This is that, and I'm done. That's a quotient. I don't have to turn it into a decimal. Does that make sense? I don't have to do the whole top dog in the doghouse and do this. It's not asking for a decimal. It just says a quotient. So that is a quotient. I can take that, rewrite it, boom, done. Now, if I'm given this problem, let's say I have this, whoops, and it's written like this, negative 20, and it asks for a quotient, I could write it like this, but I have to simplify it to that. So don't make it any more difficult than it is. It's not asking you to answer the quotient with a decimal. Okay? You can answer it with a fraction. They're rational numbers too.
So 3 negative 2 is negative 1 and
1/2.
negative,
Yeah. Right? Because it's 2 goes into 3 one time with 1
And
left over.
negative 2 over 3 is a final answer.
Boom, that is a final answer. Yep. That is a quotient. How easy, huh? Isn't that cool? You're like, oh my gosh, it was just right? Those kids was just 3. How easy is that? Yeah, just go back to the page. Yeah. So, nice. See how easy that was? Huh? But when you look at it, you're like, ah! Right? But you're like, oh wait, that's going to be a reciprocal. They're going to cancel. Boom, I'm left with just 7. Whenever you want. Yeah. You see how easy it is when as opposed to doing it the way. Now, what's great is I wanted us just to go through PEMDAS and use all those cool strategies. You just use the 2 o'clock.
I wrote the wrong.
Nice. It's pretty easy when you see the, right? When you use that lens on, you're like, it makes it so much simpler. Now you see how much easier it is than the way we're doing it every day. Oh, you didn't. They were straight. So that is 3. Boom. Oh wait, hold on. This is times. Right, because you can't add things with denominators that aren't equal. That means multiply. So that becomes 15 over 15, which equals okay. So anytime you see this, Anthony, anytime you see a number outside a bracket, that means multiply. And if you notice, this is 3/5, that's 5/3. These are that's a reciprocal of that. Right? It's flipped up. That was good. G1 is easier than what you did. You made it more complicated. But this is why. Look at that. So down here I'm dividing by 5/4. Up here I'm multiplying by 5/4. So if I'm multiplying by 5/4 up here, and then I'm dividing by 5/4 down here, that's the opposite of each other. So that means they cancel each other out. If I do one thing multiplying up here, and then I do the same thing dividing down there, I can't talk. So what's the answer to this thing? If that cancels out that, what's your answer? No, because point 2 times 1 is 0.2, right? So we have 0.2 over 0.2. What's that? Just 1. These are opposites of each other. Not opposites, they're multiplicative inverses. This and this. Way different when you see the, how much easier it is, how when you see like the inverses, right? That's multiplying. Does that make sense? So if you see a bracket beside a number, it means multiply. Yep. Those two are multiplication inverses of each other. Because if I do 0.2 times 1, I get 0.2, right? And 0.2 over 0.2?
So, like, first one, 0 and 1 over 0.
Well, let's see. Then 0.2 over. So they do cancel out. Keep going, James. What's up, Lulu? Okay, so check this out. What does that equal? What's that equal? See it now? If I have 0.2 times 1 over 0.2, what's my answer? Yes, my answer would be 3 because those are going to equal 1, right? This and that are going to equal 1. They're multiplicative inverses of each other. And because because it's multiplication, it's commutative, I can mix it all up, right? Doesn't matter. So I could go this times that, I get 1, 3. Does that make sense? gonna keep. Don't take this stuff with you.
Okay.
Okay, we're gonna keep it in here. You need one more. Wowzers. What are we doing? Where's your work? Oh, it's right there. Any questions about G? Does that make sense today?
Yeah.
Now, hey, I'm gonna tell you. When you start, because the other day you didn't see that, right? If you start noticing that, oh man, you see it all the time in math, where it's like, oh, that and that. I just get rid of them. So this is G. So you're saying G2 is 1? Okay, and then G3 is 3. I gotcha. Yeah, that was a little confusing. B3, it's funny how B3 gives kids problems. Draw it. Okay? B4, kids get. B3, I don't know. Draw it. That would be my suggestion. Draw. Draw with your power.
And if you can figure that first part out, you can figure this out.
Okay, so you should be on B3 and B4 now.
Yes.
Okay, well, you're on B1. You're on B3 and B4. Yeah. You guys do work really well. I will think you talk sometimes. I appreciate you just like separating. Makes it easy. So try to draw it. Is it making any more sense? So think about it. She or he? She. When she's running from 0, right? When she crosses 0, how fast is she going? 5 meters per second. So in 1 second, how far is she?
5 meters.
Not 5 meters, she's -5, right? Because she's running towards negative
No,
50.
I thought she was at -50 and running past 0. Yeah.
She's what?
She was at -50 and she was running past 0.
Okay, so she's at -50. When she runs past 0, she's going 5 meters per second. So when she was at 50, in 1 second, where was she?
50 or 45.
-45. 2 seconds.
-40.
Okay, that's going to help you figure that out.
Just count.
You could, yeah. That's a strategy. If you're not seeing the pattern, that's a strategy. Remember, it says division. Right?
5. Or no.
Yeah, keep going.
1.
No?
So what is
Yes.
Okay.
It's 10 seconds. Because this is your ready? This is what, I'm going to show you guys what it looks like. Michaela, look over here. You want B3 too? Yeah. Okay. It's meters per second, right? Equals a rate. That's how fast they're going, right? We know the rate. What's the rate?
5 meters per second. 5 meters per second.
Okay, 5 meters per second. So, how far did she run? What? -50. Okay. So now we have to figure out this.
50 or -10.
50 divided by 5 is 10. It's so instead of just giving you the meters and the seconds, they said the rate and the distance. So they said, hey, this, how do you figure this out? Well, then you're like, how do I get 5? Right? And we're not quite there. I'm showing you how to like do algebra, but you're like, wait a minute, if I put 10 there, that equals 5. You see how I did that, Lulu? We're kind of like dabbling, getting you guys to dabble in some algebra. Yeah. Okay, so if it repeats, then what's the word they're using for H? I forgot. It's okay. Terminate means it stops. Okay, and then repeat means it goes on. So it says state whether the fraction terminates or repeats. So if it repeats, just put repeat. And if it terminates, meaning it stops, just say terminate. Just tell me the decimal and then terminate with the decimal and repeat. So you got your fraction, right? A fraction has a numerator and a, okay? So your numerator is what they call the top dog. The top dog always goes in the, and then you do the long division. Does that make sense, Orlando? Yeah. Way easier now, huh? Oh, you're good one. Yeah, I made James struggle with it.
What?
Oh no, you weren't there then. We literally did all the math for every one of those. And it was hard because it's all like it's PEMDAS, right? It's like parentheses, exponents, multiplication, division. You know, rewrite and change and move, and man, it was difficult. But when you do it that way, it's like a piece of cake. Terminate means it stops, it doesn't keep going. So like 3/4 turns into 0.75. That's a terminating fraction. Because it goes 0.75 and doesn't keep going. 2 divided by 3, 0.6666666666666. Terminates into 0.4. Terminating means it's like this fraction does not terminate.
Repeat. Does it ever end?
What?
Does it ever end?
This is repeating fraction. Terminate means it just stops somewhere.
Doesn't 5 but that one stops?
No. You need to do long division for
Yeah,
this.
that one stops like halfway though. That one stops like halfway.
Okay? But
What?
it stops after 100. Top dog goes in the dog house. 3 goes into there, 0. 4 goes into 0, 4 goes into there, 7.
Why did you do 2?
After the decimal? Because I could put as many zeros as I wanted, but as soon as that stops, then I have to keep going. This stops right here, 0.75. This is a terminating fraction, 0.75. Make sense? Okay. Figure it out. All right, guys. Really good work today. Go ahead, put away your papers. So. Anthony, Brian's going to take those papers, and Max, Brian will grab those as well, okay? And put this one with it. Is your warm-up in there too? Where's your warm-up? Okay. Anthony, put this in that pile too. Okay. All right. Homework for tomorrow. 44 G through L. Obviously, I'm not going to have the sub come around and check homework. But if you do it tomorrow, it's done. I will be checking on Monday. I'll check it with whatever I assign for tomorrow night. I can't think of it on the top of my head. But whatever that is, I'll be checking for 2.
Is that I or L?
That's an L. G through L on page 72. Yeah, tomorrow night's homework is a lot like the work you were doing today. Looking for multiplicative identity, okay, and understanding the relationship between division and multiplication. Because multiplicative identity is that relationship. If I multiply here and I divide later, oh my goodness, I can just get rid of those. That's part of that relationship. That was our target for today. Can you do it? Today your tickets out are these 2. So, if A is less than 0, what is A?
1.
A negative number. Has to be negative. So if A is negative, what's B? Negative. So someone give me some examples of a solution. Warren.
-6 times -5.
Negative 6 times negative 5. Excellent. Maya.
-10 times -3.
Negative 10 times negative 3. Awesome.
-1 times -3.
Negative 1 times negative 3. That's really challenging, Asshole. Good one. Just joking. No. But the idea is that you guys understand that this, that a negative times a negative is a positive. That's the whole reason for this. What about that one? Because here we have a dividend, no divisor, no quotient. Right? Ben.
Negative 24 divided by negative 8 equals 3.
So negative 24 divided by negative 8, positive 3. Bingo. Orlando? Haven't got there yet? Jackie, you got one?
Wait, if you're dividing 2 negatives, will the number be negative?
Positive.
Okay, I was making sure.
James?
-24 divided by -2.
Negative 24 divided by negative 2, positive 12. See you guys. Hey, I won't see you tomorrow, so have a great weekend. Be safe.